Welcome to this video on probabilistic model in information retrieval. In today's session, we will explore how the probabilistic models are utilized in the domain of information retrieval with a focus on their fundamental concepts, formal characterizations, and practical implementations. So, what is probabilistic model in information retrieval? Probabilistic models in information retrieval estimate the likelihood that a given document is relevant to a specific query. The central idea is to rank documents based on their probability of relevance. One of the most foundational models in this category is the binary independence model, commonly referred to as BIM. In addition to BIM, several model extensions such as the BM25 have been developed to enhance retrieval efficiency. So the binary independence model or the BIM is one of the earliest probabilistic models in information retrieval. It operates on several simplifying assumptions. Firstly, it adopts binary relevance, where a document is either considered relevant or not. Secondly, it assumes term independence, meaning the presence of one term does not influence the presence of another within a document. Lastly, it considers binary occurrence, treating each term as either present or absent in the document. The primary objective of the probabilistic model is to estimate the probability that document D is relevant to a given query Q. Documents are ranked based on the odds ratio, which can be simplified using Bayes' theorem. Specifically, the model relies on estimating the probability of a term appearing in relevant documents versus non-relevant ones. So, moving on to the steps for solving Boolean iron models. So let's outline the steps involved in implementing a Boolean information retrieval model. The first step is to identify all relevant terms from both the documents and the query. Next, we build a term document matrix which captures the presence of or absence of terms within documents. Subsequently, we estimate probability, such as P of term given relevance and P of term given non-relevance. If no prior data is available, we use uniform estimates. For instance, the probability of a term appearing in a relevant document might be set to zero point 0.7, while the for non-relevant document it could be set to zero point 0.2. In the next step, we compute the score for each document using the log odds ratio formula. The formula sums up the log probability ratio for each term in the query, adjusted by whether the term is present in the query, present in the document. Finally, documents are ranked based on their computer scores, with the highest score indicating the most relevant document. So let's walk through an example. So here we have three documents: D1, which is information retrieval system; D2, which is probabilistic model retrieval; D3, which is information theory probabilistic. And the query given to us is probabilistic retrieval. So firstly, we identify all the terms in the model, which are information retrieval system, probabilistic model, and theory. The next step is build a term document matrix. Wherever uh, the term is present in a document, we give it a one number, else we give it zero. So accordingly, we form a term document matrix. Next, we estimate the probabilities of for each term, assuming p for given relevance is zero point 0.7 and p of term given non-relevance is zero point 0.2. This step allows us to compute the contribution of each term to the overall document score. So then we can compute the score for each document. So for a given document, we compute the score based on term presence and the respective probability ratios. For instance, document 2 scores significantly higher due to the presence of key terms, making it the most relevant document, while document 1 and 3 have similar but lower scores. Based on the calculation in the previous slide, the documents are ranked as follows. The document 2 with a score of 2.5, followed by document 1 and 3, each with a score of 0.33. Thus, according to binary independence model, document 2 is deemed the most relevant to the query. Now, moving on to the advantages and disadvantages of this model. On the plus side, the probabilistic model offers direct relevance ranking and flexible extension, allowing for features like term frequency and document length adjustments. However, these models also have limitations such as the unrealistic assumption of term independence and sensitivity to hyperparameters, which require careful tuning for different datasets. So thank you for watching this video on probabilistic model and information retrieval. We hope this session has provided valuable insights on how these models function and the practical applications. Thank you.